So I'm going to be going by chapter for this, chapter by chapter. I'm not going to do all the problems on here once again because I want you guys to be able to figure this stuff out. But I will do enough problems on this to show you what we're doing. And based off of that, you guys should be able to do everything. So, these first three problems, as you'll notice, they actually are very similar as you go down. So, you'll have three problems to practice for like this type. 2, 3, 1, 2, 3, and then 1, 2, 3 on each thing. Okay? So, what we're actually trying to do is that we know that logs and exponentials are inverses of each other. What that means is that when we write logs, we write log base b of x equals y. Okay? And now we can transform these into exponential functions by taking b to the y power equals x. So whenever you see something like a log, you can turn it into an exponential, and this actually helps us solve some problems. So, for example, in this first one, what I'm going to try to do is I'm going to find my b, my x, and my y. So my b is always the smaller part right here. So I'm going to look, okay, so if b is the smaller one, right? So since b is the smaller one, that means that it has to be the letter x. My x is the bigger number that's next to the b. So I'm going to look at the bigger number, that's 243. And my y, okay, is past the equal sign. So my y is right here. So I see that my y is right there. So I'm going to say y equals 5. Alright, now that I have my b, my x, and my y, what I can do is transform it into an exponential function. So my b is x, I'm going to take x to the y power, which is 5, equals 243. Now you have two ways you can actually solve this. The first way is to use your calculator and you start plugging in numbers, like, I don't know, you start with 7. 7 to the 5th power. You start figuring out what number gives you 243. Alright, in this case, we could start plugging around until we get to 3, and we figure out 3 to the 5th power equals 5. That gives me 243. So I know x equals 3. Now the other way to do it like this is to actually break this down. Figure out what goes into 243. Well, once you play around, you'll figure out that 3 and 81. Then you break down 81 into 9 and 9. You break down 9 into 3, 3, 3, and 3. Which is the same as saying 3 to the 1, 2, 3, 4, 5th power. So that means that 3 would be our answer here. Okay? This next one is actually the easiest of the three types that we are going to get. Your b is 5, your x is x, your y is 3. So when I transform this into an exponential equation, I take the b, which is 5, to the y power equals x. So since we already know 5 to the 3rd power, we can actually figure that out pretty easily. This is easy to find this letter right here. So what we do is you take 5 to the 3rd power, figure out what that is, that's 125. So my answer for x is 125. And then this last one right here, same idea. We're going to find our b, our x, and our y. Little number is 9, number next to it is 81, and y is x. So this one is 9 to some power, gives us 81. So this time we can just guess and check. We can try 9 to the 1st power, 9 to the 2nd power, whatever it is. Well, once you get to 9 to the 2nd power, you realize that's 81, so x has to be 2. So remember, that's how you do this one. Shows you how to do the same thing for this one and this one. The middle one is for all three in the middle. This last one's for all three at the last spot. Okay? Now, to go along with our log rules, we've got other rules that we can talk about. We know that if you have log of some letter to and you subtract log of some some number down here. If you're subtracting, you're actually just taking the x and the y, and you're just dividing it, x divided by y. What that means is that whatever number's here, if you take this number divided by this number, the answer doesn't change this log with this little number here. It just changes the last answers. Another thing that we know is that we know that log base b of x plus log base b of y, if you're adding, subtracting is division, adding is multiplication. And the last idea that we're going to talk about is when you have an exponent. Now, if you have an exponent and you are actually trying to expand it, this thing goes to the front. So actually the exponent, you can always, exponent of anything that's being taken to a log can be moved to the front. So the y moves to the front, the log base b doesn't change, and the x doesn't change. All that happened was we took the exponent and moved it to the front. So this is going to help us with these next parts. Okay, so I'm going to skip these first two because these are kind of easy. I'm going to do one like this, okay, where it's just plus and minus, and then I'm going to do this one right here, which has the numbers in front, okay? So first, let's do this one right here. Now, I know that plus means multiplication. So here, the log base 5 does not change. What changes is that we're going to take 16, we're going to multiply it by 4. So 16 times 4, well, that gives me 64. Also, sorry, if you're still watching this, the second one right here, it's either this one or this one. I think it's this one doesn't work. So skip that one. But yeah. So then we have log base 5 of 8. Okay. Now we have the minus left. Minus means division. So I'm going to take 64 and I'm going to divide it by 8. So 64 divided by 8 gives me 8. So the log base 5 did not change, but my final answer is just 8. Because remember, first we multiplied 16 times 4 gave me 64. And then 64 divided by 8 gave me 8. Now, that uses our first two rules that we talked about. The second two rules the last rule we talked about was this number in front. So, just like I said, if there was an exponent here, you can put it in front. So if there's a number in front, that means we can put it as an exponent. Okay? Same thing with this 3 here. We can put that as an exponent. We have no number here, so we can't put that as an exponent, but that's what you should do before we do anything else. So we're going to rewrite this to be log base 4 of 12 squared plus log base 4. This part doesn't change, remember. Only the bigger number is going to change. 6 to the 3rd power minus log base 4 of 3. So first, let's figure out what 12 squared is. Well, I know 12 times 12 gives me 144. Plus log base 4, 6 to the 3rd power, 6 times 6 is 36. That times 6 is 216. Minus log base 4 of 3. Now that we've gotten those numbers in front out of the way, what we can do now is actually multiply first. So take 144 times this. So if we take 144 times 216, that's going to give us log base 4 of 31104. And then this minus log base 4 of 3. So since this is a minus, we're going to take this number and we're going to divide it by this number. So we take that number divided by that number. We get log base 4 of 10,368. And that would be our final answer. Okay? Now, that's how you reduce. Now let's learn how to expand. Okay? So when we're expanding, so I'm going to do this problem right here, okay? Because this is probably one problem that contains everything that we can do. So first, let's look at what's happening. We see a multiplication sign. I know that's going to be a plus sign at some point, okay? Because multiplication is the same as addition when it comes to logs, okay? And then we have this division sign here. I know that's going to become subtraction at some point. So everything was condensed to this. So what we're going to do now is we're going to expand it out. We're going to try to make it look like something like this up here, okay? So we're going to expand that out. So I know there's going to be a plus, and then I know there's going to be a minus. Now this log base 6, once again, is the thing that doesn't change. And we need that everywhere. Otherwise, this problem won't be the same thing as when we started. So I'm going to put the log base 6 because that's not going to change anything. What comes next is what comes in order. So first we see the 3 to the 7th power. Then we see the 4 to the 3rd power. And then we see the 2 to the 4th power. Okay? Our next step here would be to look at this. Okay, so we've got everything. We got the plus and minus. The last thing is to figure out, all right, what am I going to do with these numbers up here? Well, I know that they go in front. So this ends up being 7 log base 6 of 3 plus 3 log base 6 of 4 minus 4 log base 6 of 2. And that's what it would end up happening. This would be the final answer. This is expanded out. All right? Before we were trying to shrink, this one we expanded. All right? This next part's actually really easy. If you do not have a number right here, if there is no number right there, we can actually just plug that into our calculator. So for example, all I have to do here is, you see how it says log of 937 is on our calculator, we press log 937. Okay? And then round to the first 2 decimal places. So my answer is going to be 2.97. There's actually nothing difficult from there on. That's it. That's all we're going to do. Alright? And now, we're going to move to the next one. This should be a point. It's hard to see, but that should be a point right there. The next part is actually trying to find the value of x if we have an equation. So once again, we're going to go back to this idea. Log base b of x equals y. Alright? And then b to the y power equals x. So, what we need to do first is we need to find our b, our x, and our y. There's a problem here. We don't have any number here. Okay? This is actually a lot easier than we think it is. I'm going to do this middle one because this is probably going to be the hardest ones that you're going to have to do. So, this middle one right here, what we're looking at is this thing right here, alright? So what I'm going to do is first find my b. Since I don't have one, I know it's going to be 10. It's something that you just have to remember, is that if you don't have a letter there, or if you don't have a number there, it's going to be 10. My x is everything next to the log before the equal sign. So in this case, it's 15x minus 5. And then finally, your y is the thing after the equal sign, which is 3. So let me change this. It will be b, which is 10, to the y power 3 equals 15 minus 5. So you put this in your calculator. Usually you'll get a decimal, but this one's actually nice where we're not going to get one. you're going to get 1,000. If you do get a decimal, round to the nearest whole number. Sorry, this should be 15x. 15x minus 5. And from here, you just actually solve. So first, I'm going to get rid of this 5 by adding 5 to both sides. This crosses out. This gives me 1,005 equals 15x. And then I just solve for x. Divide by 15, divide by 15. X gives me 67. Okay, and that's my answer. Now the last thing in this chapter is to find the exact value. We're going to find the exact value by using the change of base formula. Now the change of base formula is this. We have everything looking like this, log base b of a. Okay, to do the change of base, we're going to take the log of a. Alright, so that means that this number's missing now. Log of a over the log of b. The reason why we can do this, the reason why we're doing this, is because we can actually plug this into our calculator. So I'm just going to do one of these just to show you. First, we have to figure out what a is. A is the bigger number right here. So the bigger number here is 36. So I'm going to put 36 down. Little b is the little number, so this would be 6. So in this case, I'm going to take log of a, so that's the log of 36, and divide it by log of 6. And so I can just put that in my calculator. Log of 36, close the parentheses, otherwise your calculator will get confused, divided by log of 6, close your parentheses. And you get the answer 2. Normally you guys will get a decimal, but in this case it worked out good. So the answer is 2. And that's everything for